Okay, lesson 38, simplifying expressions using the GCF. Okay, from this we need to know, first of all, the way you've seen this before is either through a, let's say, a factor tree. It's probably what you guys are most commonly used to seeing. So on a factor tree, it would just split out. For example, this one would be factors of 24, which is 4 and 6. But then 4 has factors of 2 and 2, and 6 has factors of 2 and 3. So now I have my prime factorization at the bottom. Another way that you might have seen this as factoring is you might have just seen it look like this, 6 times 4, and then it got broke down even farther into 2 times 3 and 2 times 2. I think that's the only two ways that I've seen y'all guys learn this. So is there any other ways that y'all guys know to factor something out that I'm missing out on? No? Alright, so the most common one you guys should be familiar with is a prime factorization tree, and this will stem off of that, but I'm going to show you a way to do it in the calculator that'll show you how to do it a lot quicker, and it'll be a lot more accurate, and you will never ever miss it. But you still need to know how to do prime factorization. Okay, so on the first couple that we do, we're going to do it the long prime factorization tree. Okay, so you have two methods that we'll use. So we're going to use prime factorization tree. So the first one, I want to find numbers that will go into this that are larger. Okay, the larger the number, the shorter my tree will end up being. Okay, so here I'm going to go with 10 and 12. Those are kind of two large sets of numbers, and then factor out again 2 and 5. Then here I factor out 12. I get 2 and 6 or 3 and 4, either way. I'll do 3 and 4, and then 2 and 2. So my numbers at the end are here, and these are all prime numbers, prime factorization. If I want to write it out as prime factorization of 120, I just throw an equal sign next to it, and then I put all the numbers that I have circled at the very bottom, the very last pieces, in the top, and I put them together. So I'm going to put 2 times 2 times 2, because there are 1, 2, 3 2's, and then times 3 times 5. And another way to write this, because now I know what my exponent rules tell me I'm allowed to do, when I multiply things with like bases, I can add their exponents. So that's 2 to the third, because there's 3 of them, times 3 times 5. And that's a lot shorter way to write it, and it looks a lot neater than seeing 2 written out 3 times. Okay, so you're able to do that. Questions there? Alright, so here's a bigger one. This is a prime factorization of 924. Much larger one, actually. Okay, so we want to look for numbers that will go into 924. If you don't know where to start, ask yourself the question, does it go into 2? And how do we know if something goes into 2? If it's even, right? And it is even. So yes, I want to start out with larger numbers, but if I don't know where to start because it's such a large number, I'll just start out with 2. And then the next question, if it doesn't go into 2, I'll ask if it goes into 3, and you can go through that step. Okay? So if it goes into 3, obviously we'll go into there. Now, do y'all guys know a trick for how to find out if it goes into 3? Right. So if you add all these numbers together, and if that is divisible by 3, then the whole thing is divisible by 3. So let's run a quick test and see if it is divisible by 3. 9 plus 2 is 11, and 11 plus 4 is 15. And 15 is divisible by 3, so it would be divisible by 3. Okay, just another rule, kind of interesting rule that works. Okay, so we went with 2 just because it was even and it was the most obvious one. So 2 and 462 go into that. And then again, I see that I have another even number. So I could again do that, divisible by 2, or if I notice finally that it was divisible by 3, I could do it divisible by 3. Since the most obvious one is divisible by 2, I'm going to go ahead and do that. So that's 231. Now I got a problem, because that's not divisible by 2. Let's see if it's divisible by 3. So we have 2 and 3, which make 5. 5 and 1 makes 6. So I know it's divisible by 3. 3 and 77. Is this anybody's iPad back here? Okay, so our 231 divided by 3 gives us 77? Yes. Okay, now I see 77. How do I know what that one's divisible by? How do I know that? Because it's the same number repeated, right? each digit's the same. I get you. So since it's a 7 and 7, I know it's divisible by 11 and 7. Is all the numbers at the bottom prime? Okay, so I'm going to circle them all just so I know which ones I'm writing down and I don't forget. So I have 2 2's, so that's 2 squared. I have 1 3, 1 7, and 1 11. Okay, I just put them in order. Any questions there? Okay, so what we're going to be talking about is the greatest common factor of monomials. Monomial just means one term. Okay, monomial just means one term. So GCF is finding the largest monomial that divides without any remainder to each of the terms in that polynomial. So on example 2, this is where we're going to start learning on our calculator a little bit. It gives us 6a squared b to the third plus 8a squared b squared c. So I have to find out what each of these have in common. So basically I would do a factor tree. But see how this one is written out? See how it's 2 squared, 3, 7, and 11? All I can do is do the prime factorization of the coefficient, and then as for the rest of this, I would just expand it back out to a times a and b times b times b. So what is the prime factorization of 6? That's the first question we have. 2 and 3, right? So I have 2 and 3, and then I'm just going to expand the rest of this. So a squared is a times a, and then b to the third is b times b times b times b. So 3 b's, right? So I've just expanded everything. So once I got that expansion done, I'm going to expand the next term immediately underneath it so I can see what they have in common. I want to see what they have in common. So do I know the prime factorization for 8 yet? 2 times 2 times 2. It would be 2 times 4, and then we'd expand 2 times 4 to 2 times 2, right? So we get 2 times 2 times 2. This is all being added together. And then I expand my a squared, which is a times a. And then I expand my b squared, which is b times b. And then I expand my c, which is just c. Okay, so now I have the whole thing expanded. So in order to see what the greatest common factor for all of these would be, I'm going to stack them on top of each other. So I take the expanded versions of each, and I stack them right on top of each other. So I have 2 times 3. I'm going to do it kind of big so you can see it. Then a times b times b times b. On the other one I have 2 times 2 times 2 times a times b times b times c. Now I want to see what each of them have in common. So I'm going to circle the things that they have in common. So here I noticed that there was a 2 and a 2 that they had in common. There was an a, there's another a, there's a b, there's another b, and that's it. Okay, so everything that they have in common, I'm going to write it down below. So they had a 2 in common. They had an a in common. They had another a in common. They had a b in common, and they had another b in common. So now that I have it in its expanded version, I'm going to push it all back together. And did I write it down wrong? No, they both have a squared, actually, right here. Okay. So here I have a 2, so I just carry my 2, and then I had my 2a's, so that's a squared, and I have 2b's, so that's b squared. So my greatest common factor is this right here. So if you don't have it written in there, put a little note, GCF. This is my greatest common factor. The things that they have in common with each other is the greatest common factor. Okay, so let's take out our calculator and I'll show you how to do the greatest common factor of the coefficients. So this works with any number that you need to find the least common multiple of. So if you type in, turn on your calculator first of all, go to math, go over to number, and then scroll down, you'll see one that says GCD. math is right below the alpha button. Is everybody there? Go over to number. GCD is like 9 on mine anyways. It's on 9. Hit that button. Now if I wanted to find the GCD of 6 and 8, I type in 6 and then comma, there's a comma right here, and then 8. Close the parenthesis. Press enter, it should spit out a number. So of course it was 2, because we already found that out on our calculator, or on our paper. But that would work for larger numbers, for something that you wouldn't know right off the top of your head. Okay, so there's your GCD. It was 2 in this case. If I wanted to find out, again, let's test another one. Go to GCD of, let's say, 120 and 96. Press enter, spits out a number. My GCD here would have been 24. So it's nice. It tells me what factors they have in common and puts them together for me. Okay, so just a quick way, if you ended up with something like 924 and 120, that would be kind of hard to find what the GCD would be. So your calculator also does that for you. It also does least common multiple. That's another function in there if you want to play with it later. Okay, so that's a quick way to get your number part of it. But for the rest of it, the letters, you have to look at it as, what is my greatest common factor? Now, at first we just find greatest common factor, so we found our greatest common factor, and there it is. Let's do part B of this one. Part B has, and because it's only asking for greatest common factor, I suggest that you do this. Since I know what the problem is, on your work, all you would want to write down is the terms themselves. So 8C4D to the second E. So I'm going to write them down just like that. 8C to the fourth D squared E. And then I'm going to factor it out and write out the big long expanded version right here. And then immediately underneath that, I'm going to write the next term, which was 12C to the third D to the fourth E squared. And I'm going to expand that one out. Okay. So first of all, I need to find out the prime factorization of 8, or I can just type it in on my calculator and find out what it is. Prime factorization of 8, since we already did it, was 2 times 2 times 2. Then we need to find the prime factorization of 12, which was 2 times 6, and then 6 breaks down into 2 times 3. So we have 2 times 2 times 3. Those are just for our coefficients. Next, I just expand out the variable and its exponent. So it's c to the fourth, so it's c 4 times. 2, 3, and 4. And then d, it goes d twice. And then e just once. Moving on to the next one. I have c 3 times. 1, 2, 3. We have d 4 times. 1, 2, 3, and 4. And then e twice. 1, 2. I just go through there and I circle what they have in common. I have 2, another 2, we have C, C, and C. See your future at C, C, C. D and D. And then we have E's in common. So now I'm just going to write everything straight down that I have circled. So I have a 2, I have a 2, I have a C, 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 I have D, D, and E. So there's my greatest common factor, but I need to write it in a more pleasing way. So 2 times 2 is 4. C times C times C is C to the third. D times D is D squared. Whoops. D squared. And E is just E. So there's my greatest common factor. GCF. Okay. Questions thus far? There is a trick to this if you feel like you can handle it. If you look at these, I would just find the GCF in my calculator, type that in, 8 and 12, it'll spit out 4. And then I look at what they have in common. They both have a C in common. How many C's do they have in common? They have 3 C's in common because this one cannot go higher than that one. So look. I found out that I had 4, I had 3 C's, and then I look at my D's. They have 2 of the D's in common, so there's the D. There's e's, and there's only one e in common, and look, there's the e. So without expanding this whole thing, there is a trick you can do just by looking at it. Okay, next one. Example 3. If I have a polynomial meaning many terms, okay, and in this one it's 3 terms, so it's 6x to the third plus 8x squared minus 2. If I want to find out what the GCF of this whole thing is, oh sorry, 2x, my bad, I would expand each term and put them on top of each other. So I take the first term, I find out that the prime factorization of 6 is 2 and 3, so I'd expand 6x to the third into 2 times 3, and then I have 3 x's, so it's x, x, x. Next one I have to expand is 8x squared, and I've already expanded 8 a couple times already, so I already know it's 2 times 2 times 2, and then it has 2 x's, so x and x. And the last one is 2x, and it's already prime, so it's just 2 and x, 2 and x. So you might be wondering why I spaced that out. It's just so that when I do my circle, it's not so weird. Okay, so now I've got everything expanded. I lined up my 2's so it would be easier to circle them. I lined up my x's so it would be easier to circle those. And that's all that all 3 of them have in common. We're looking for only the things that all 3 of them have in common. So I had a 2 and I had an x, so my greatest common factor is simply 2x. And again, I could have looked at it and said, what would be the thing that they have in common? What can I pull out of each of these? I can pull out 1x. Okay, so I found out there's 1x. And then what is the greatest common factor of those? It's 2. Okay, so again, you can look at them and see the same kind of concept. I'm going to test and see if your calculator can do that for us. 6, 8, and 2. Okay, calculator can't do 3 numbers. Sorry. It can only do 2. So it won't be a whole lot of help there. Alright, so there's example 3. And again, you just expand each term and look for what they have in common. And what they have in common is your greatest common factor. Okay, example 3b. They give us 9x to the 4th y squared minus 9x to the 6th y. Without expanding this, what do I know about my coefficients since they're both 9? What is their greatest common factor? No. It's 9. If both of them are 9, their greatest common factors are 9. Okay? I'll show you how that translates when we're getting into it. So we have 9x to the 4th y squared that we need to expand. So we know that the prime factorization of this is 3 and 3, right? So here we go. It goes 3 times 3, and then I have 4 x's, 1, 2, 3, 4. I have 2 y's, 1, 2. Then I need to expand 9x to the 6th y, and we already know the prime factorization of 9 was 3 and 3. I have 6 x's, 1, 2, 3, 4, 5, 6, and 1 y. So again, find out what they have in common. I circle them all up. I have 1, 2, 3, 4 x's in common, and 1 y. So I have 3 times 3 times 1, 2, 3, 4 x's, and 1 y. Combining all that all together, I get 9x to the 4th y. And again, when I look at this, I see that my smallest x was x to the 4th. Look, commonalities are translating. My smallest y was just y. So again, translated down. Okay. So this is my greatest common factor that can come out of both of those. So when I rewrite this, if it's not just asking us to find the greatest common factor, it'll say something to the effect of factor out the polynomial or factor each polynomial completely. So when I find my greatest common factor, I'm going to do this. So there's my GCF. I'm going to write it down. 9x to the 4th y. Put a little note there, GCF. And I'm going to open a set of parentheses. And then I need to look at this. I need to go, if I pull a 9 out of here, what's 9 divided by 9? 1. So if I pull a 9 out of here, the 9s would, in essence, cancel out, right? So the 9s would go away. If I take an x to the 4th and I divide it by an x to the 4th, again, that would cancel out. Then if I pull one y away from this y squared, I'm left with just y. So what I'm doing is I'm rewriting it with minus all of the things that are in here. I'm taking away all of the things that are in there. It's really a division kind of a deal. Okay, so if I took 9x to the 4th y squared and divided it by 9x to the 4th y, I would notice that that cancels, this cancels, and when I move this to the top, it becomes minus 1, and I'm left with just y. And the same kind of concept would happen with our second term, because it's just being subtracted. Our 9x to the 6th y over our greatest common factor, 9x to the 4th y, those would cancel. When I move this to the top, it becomes minus 4, and those would cancel. So I have x to the 6th minus 4, which is x squared. That's all that's left. So when it says factor it out, it's looking for an answer that looks like this. So I pull all of this out, and if I re-expanded it, if I went ahead and redistributed it, I should get my original answer. Okay, so that's factor out as far as we can factor it out. Questions? Okay, example 4 then, and I think that's our final example. No, there's one more. Example 4, simplifying algebraic fractions. So if we want to simplify an expression that has a fraction in it, we're going to look first for its greatest common factor. So 3p plus 3 over 3. But before I factor something, before I can simplify something, I must factor it. So what is the greatest common factor of 3p and 3? 3, right? I can pull out a 3 and put the rest in parentheses. So if I pull a 3 out of this, what's left? Just p. If I pull a 3 out of this, what's left? What's 3 divided by 3? 1, right? So if I pull a 3 out of it, I'm left with p. If I pull a 3 out of this, I'm left with 1. So I've now completely factored that, which is nice because when I factor this, those 3's allow me to cancel them out. So all I'm left with now is p plus 1, and that would be my final answer. Simplified final answer. Okay? So that was part A. Part B gives us another fraction. It says 5x minus 25x squared. And then we have 5x multiplied by y on the bottom. Looking at this 25 and 5, what is the greatest common factor of 25 and 5? It's 5, right? Now looking at just my exponent part, what is the greatest common factor of x and x squared? It's x, just one x, right? Because I can't take x squared out of just an x, but I can take an x out of an x. So when I take 5x and I divide it by 5x, what am I left with? 1. When I take 25x squared and I divide it by 5x, let's deal with this piecewise. When I take 25 and divide it by 5, what do I get? I still get 5, and it's negative, right? Then when I take an x squared and I divide it by an x, what am I left with? X squared divided by x, what am I left with? Just x, right? So that's what I'm left with up top. Now on bottom I had 5x multiplied by y. So I should notice, since it's all multiplied out and this is factored up top, my 5's canceled, my x is canceled, so all I'm left with now, I gotta erase my little side note here so I can have room. All I'm left with now is my 1 minus 5x up top, and on bottom all I have is a y. And that's as far as I can go with that, because there's nothing else left for me to factor. Can't factor out anything else. Questions? Okay. On example 5, we're going to deal with a height problem. These are formulas that you're going to see a lot in your mathematical career, so get used to seeing this type of formula. So when something is dropped, it falls at negative 16 t squared, t being time, plus 72t plus 12. It falls at that rate, okay? So equals your height at whatever time you're evaluating this at. So that's our formula. It says it can be used to represent the height of an object that is launched in the air from 12 feet off of the ground with a velocity of 72 feet per second. Rewrite the formula by factoring the right side using the greatest common factor and making it in a positive term. So making the t squared term positive. So it's saying that I have to make this term positive. So how do I get rid of a negative? I can factor out a what? If I have a negative x and I want to get that to be positive, I would rewrite it as a -1, right, with x inside my parentheses. Now my x is positive, but it's being multiplied by a -1. But this term right here is positive. So if I want to factor out and make something positive, I would factor out a negative. So it's saying make this front piece positive, right? So in my very first thing, I'm going to rewrite, I'm going to set up a parenthesis because I know I'm factoring, and I need to get rid of this negative. If I factor out a negative out of this, I have to factor out a negative out of the whole thing. So since this was positive and I factor out a negative, it's now going to be a negative. Since this is positive and I factor out a negative, it's going to be a negative. Okay? Now, I need to look. Do they have any common variables in each term? Well, it has t in the first two, but it's not in the third, right? So I can't factor out a variable if they're not in all three terms. However, when I look at these, is there a greatest common factor for 16, 72, and 12? 2 definitely goes in there. Is there anything bigger than 2 that would definitely go into each of those? Say that louder. 4. Yeah, 4 definitely goes into each one of those as well. So I can factor out a -4. I factor out the negative because I don't like dealing with leading coefficients that are negative. Okay, so when I factor out a -4 from 16, I get a +4. And then my t squared, because I didn't change that at all. And then when I factor out a -4 from 72, I get a negative, or a -18, and t is still there because we didn't do nothing with it. When I factor out a -4 out of a +12, I get a -3. Okay, just deal with it like you're looking at division. If I factor out a -4 out of each of these, what do I get left with? Okay, so these drag down, drag down, drag down. But in order for it to be true mathematically, I have to write my -4 on the outside of a parenthesis. Otherwise, I'm changing it, and you can't just do things by magic. Okay, do we got anything that we need to go over?